Hello, my name is Daniel, and today we will be going through the AMC 12A from the year 2009. So let's get started. First problem. Kim's flight took off from New York at 10:34 a.m. and landed in Miami at 1:18 p.m. Both cities are in the same time zone. If our flight took 8 hours and M minutes with M between 0 and 60, what is H plus M? An easy way to think about this is from 10:34 up to let's say midday, noon, and then from here to 1:18, right? This much, that is 1 hour and how many minutes is that? 26 minutes, and this is 1 hour 18 minutes, obviously. So those summed will be just 2 hours and 44 minutes, right? So it's 2 plus 44, that gives us 46, and that's the answer. It's A. Number 2, which of the following is equal to this? Okay, so let's just do this step by step. This is 1/2, so 1 plus 1/2 is going to be 3 over 2, and then that over 1, that's going to be 2 over 3, 2 over 3, and so 1 plus 2 over 3, this is going to become 5 over 3, right? So 5 over 3 is the answer. It's C. Number 3, what number is 1/3 of the way from 1/4 to 3 over 4? Okay, so the distance between that, so the distance is 1 over 2, and so 1/3 of that distance, 1/3 of it is equal to 1 over 6, right? And so it's 1/3 of the way from 1/4, and 1 over 6 more of that, so it's 1 over 4 plus 1 over 6, which is equal to all over 12, and it's 3 plus 2, that's 5 over 12. So that's the answer. It's B. Number 4, 4 coins are picked out of a piggy bank that contains a collection of pennies, nickels, dimes, and quarters. Which of the following cannot be the total value of the 4 coins in cents? Okay, so since all our answer choices, they are multiples of 5, right? And we pick up 4 coins, right? And so that means pennies cannot be picked out, right? So that means only nickels, dimes, and quarters. And so that means the fewest amount, those are 4 nickels, right? 4 nickels, which is 20 cents. And so the value less than 20 cents, that's 15. That cannot be the value because 15 is a multiple of 5, but it's less than the fewest number, right? So the answer is A. Number 5, one dimension of a cube is increased by 1, another is decreased by 1, and the third is left unchanged. The volume of the new rectangular solid is 5 less than that of the cube. What was the volume of the cube? Okay, so let's say that the cube had side length A at first, so the volume would be A cubed, right? And then A cubed, one dimension is increased by 1, one more is decreased by 1, and the third is the same. So this becomes A times A plus 1 times A minus 1, right? Which is A cubed minus A. But then the volume of the new solid is 5 less than that of the cube, right? And so this will be, this is going to be equal to A cubed minus 5, and so we just see that A equals 5. A equals 5, so A cubed, this was the volume of the cube, that is 5 cubed, which is 125. So this is the answer, 125, it's D. Number 6, suppose that P is 2 to the m power and Q is 3 to the n power. Which of the following is equal to 12 to the m(n) power for every pair of integers m, n? Okay, so 12 mn, this is equal to 2 to the 2mn, 2 to the 2mn times 3 to the mn, right? And so this is equal to 2 to the m times 2n multiplied by 3 to the n to the mth power. This is p2m, p2n qm, right? So this is the answer. It's E. Problem number 7. The first 3 terms of an arithmetic sequence are 2x minus 3, 5x minus 11, and 3x plus 1 respectively. The nth term of the sequence is 2009. What is n? Okay, so the common difference, they will all be the same, right? So we get that these two, they give us 3x minus 8, right? And then these two, that gives us 12 minus 2x, right? So 3x minus 8 equals 12 minus 2x, so 5x equals 20. Right, 5x equals 20, x equals 4, right? And so that means we start at, if x is 4, then we start at 5, and we add 4, right? Add 4. This can be expressed as 4n plus 1, right? And then we want the nth term to be 2009. This equals 2009, and so that means n equals 2008 over 4, which is 502. So this is the answer. It's B. Number 8, 4 congruent rectangles are placed as shown. The area of the outer square is 4 times that of the inner square. What is the ratio of the length of the longer side of each rectangle to the length of its shorter side? So here we have a line from here to there, a line from here to there, and like that, right? Because it said that the area of the outer square is 4 times that of the inner square, right? And so is the inner square, its area is 4, and the outer square area is 16, so that makes sense. And what is the length of the longer side of each rectangle? So this is each rectangle. So the length of the shorter side, it's 1 to 3, right? So it's 3, it's A. Number 9, suppose that fx plus 3 equals this, and fx equals this. What is a plus b plus c? Okay, so to get fx and not fx plus 3, then what we need to do is plug in x minus 3 instead of x, right? And so if we do that, then we get 3 times x minus 3 squared plus 7 times x minus 3 plus 4. This equals 3x squared minus 18x plus 27, and then plus 7x minus 21 plus 4, right? This is going to be equal to 3x squared minus 11x plus 10. And so this is equal to ax squared plus bx plus c. So a plus b plus c is 3 minus 11 and 10. So that is 3 minus 11 plus 10, which is equal to 2, right? So 2 is the answer, it's D. Number 10, in quadrilateral ABCD, AB is 5, BC is 17, CD is 5, DA is 9, and BD is an integer. What is BD? Okay, so we have this is 5, 9, 5, and 17, right? And so if we call BD X, then this is a triangle, so by the triangle inequality, 17 is the longest side, so 5 plus X, so 5 plus X is greater than 17, that means X is greater than 12, right? And so, and then for this triangle, that also gives us 9 plus 5, that gives us 9 plus 5 is greater than X, so X is less than 14, right? And since X is between 12 and 14, that means X is equal to 13, so 13 is our answer, it's C. Number 11, the figures f1, f2, f3, and f4 shown are the first named sequence of figures. For n is greater than or equal to 3, fn is constructed from fn-1 by surrounding it with a square and placing one more diamond on each side of the new square than fn-1 had on each side of its outside square. For example, figure f3 has 13 diamonds. How many diamonds are there in figure f20? It's hard to notice in the first 3, but then by the time that you get to f4, then you actually can notice a pattern, right? Because if you just see the odd numbered ones, right? So the third one and the first one, they form a 3x3 grid, and same thing for the even numbered ones, they form a 4x4 grid, right? And the red one was a 3x3 grid, and so this gives us that it's a 3 squared plus 4 squared when it's f4. And we see that fn equals n minus 1 squared plus n squared, and that holds true for this one too, because it's 2 squared plus, and then we have 3 squared, right? Like that. Same for f2, and obviously for f1 also, right? And so if we say that we need f20, so if n equals 20, f20, this is going to be equal to 19 squared plus 20 squared, which is 361 plus 400 equals 761, right? So this is the answer, it's E. Number 12, how many positive integers less than 1000 are 6 times the sum of their digits? Okay, so let's say since it's less than 1000, they have maximum 3 digits. Yeah, so if it's ABC, it's 100A plus 10B plus C, right? This is 6 times their sum, so A plus B plus C. And so if we move C over there and A plus B over here, right, then that will give us 94A plus 4B is equal to 5C, right? And since A, B, C, they have to be 1-digit integers, that means A must be 0, because A not being 0, that would result in like terrible things, right? So A is equal to 0, and so if 4B equals 5C, then the only way is for B to equal 5 and C to equal 4. So the only answer is A equals 0, B equals 5, and C equals 4. This is the only way. So 54 is the only way. So 54, that's just 1, so the answer is B. Number 13, a ship sails 10 miles in a straight line from A to B, turns through an angle between 45 and 60 degrees, and then sails another 20 miles to C. Let AC be measured in miles. Which of the following intervals contains AC squared? Let's just say that it is 45 degrees. First of all, the line from A to B, that would just continue like that, and from C, it would just fall like that. And this would be a right angle. This would be 45 degrees, and so the angle ratio, that would just be 1 to root 2. So that would be, so this side would be 10 root 2, and this side, that would also be 10 root 2, right? And then which of the following intervals contains AC squared? So AC squared, this is this much squared plus this much squared, so 10 root 2 squared plus 10 root 2 squared, which is 10 squared times, and then root 2 squared plus 1 plus root 2 squared. And so this is 100 times 2 plus 1 plus 2 plus 2 root 2, right? So this is 100 times 5 plus 2 root 2, which is about 2.82, right? So this is 782 point something something something. This is between 700 and 800, so that's our answer. It's D. Number 14, a triangle has vertices 0, 0, 1, 1, and 6, 0, and the line y equals mx divides the triangle into two triangles of equal area. What is the sum of all possible values of m? Okay, so if we have those coordinate plane, and we have 0, 0, and then up to 1, 1, like that. Right, so let's say this is 1, 1, and then 6m, 0, that would go down, that would go down like that, right, like that, and let's say this is 6m. And then y equals mx, that divides the triangle into two triangles of equal area, and so that would look something like this. This would be y equals mx, right? If you look at this first triangle that has a base of 6m and a height of 1, if this line divides the triangle into two, that means half of this is equal to this, right? And so this much is half of the whole thing, but it has the same base, right? So this times this, that is 2 times this times this. That means this length must be half of this length, right? And so that means this, so this must be the midpoint of 1, 1, and 6m, 0, and that this y value must be 1/2. So this gives us that it's midpoint of 6m, 0 and 1, 1. So this is going to be 6m plus 6m plus 1 over 2, 1 over 2, right? And then the sum of all possible values of m. So since this is the midpoint, but that's also on y equals mx, right? And so if we just plug this into here, then that will give us 1/2 equals m times 6m plus 1 over 2. If 2 and 2, and so if 2 and 2 cancel, that means 6m squared plus m equals 1. And so 6m squared plus m minus 1 equals 0. Right, and so this will give us values like 1, 1, and then 3, 2, and so that will give us, m equals 1 over 3 and negative 1 over 2, and these values both work, right? So their sum would be negative 1 over 6, and so this is the answer. It's B. Number 15, for what value of n is I plus 2i squared plus 3i cubed plus all the way to ni to the nth power equal to 48 plus 49i, and I is root of negative 1. Okay, so if we just list the coefficients of I and 1, the first one's going to be 1, 1i, and then it's going to be negative 2 because this becomes minus 1, and then we're going to have minus 3i, and then we're going to have plus 4, like that, right? The next one's going to be 5, minus 6, minus 7, 8, and we see that i's keep going smaller by 2, and 1's keep going added by 2, right? So same thing here, minus 2, and this will be plus 2. And so we see that for every group of 4, then it becomes 2 minus 2i is added, right? And so to get close to that, after 24 groups of 4, that will be 48 minus 48i, right? But then since this is after 24 groups of 4, that means this is equal to 96, that this is equal to the 96th power. And so the 97th one, that would be 48 minus 48i, right? 48 minus 48i, and then that will be part of 1i, right? So this will be plus 97i, and this is equal to 48 plus 49i, which is what we want in the first place, right? And so it's the 97th one. The answer is D. Number 16, a circle with center C is tangent to the positive x and y axes and externally tangent to the circle centered at 3, 0 with radius 1. What is the sum of all possible radii of the circle with center C? If we just bring up a drawing of center C like this, right? And so this is going to be 3, 0. This radius is going to be 1, right? And so we can have the circle. It can be either right here, or it can be much bigger, like something like that, right? Like that. It is going to touch here, right? As well as touch the y-axis, as well as this point, right? And so we have two values, and so if we just calculate the value for this one, then it will just be the same, right? And so if we make this right triangle, right? Let's say the radius is r, if this is r and this is r plus 1, right? Since this much is 1 and this much is r, and since this whole thing is 3 and this is r, that means this much is 3 minus r, right? And since this is a right triangle, if we use the Pythagorean theorem, we get that r plus 1 squared equals r squared plus 3 minus r squared. So 2r plus 1 equals r squared minus 6r plus 9. And so r squared minus 8r, so r squared minus 8r plus 8 equals 0. And so the sum of this is going to be 8 over 1, which is 8, right? And so 8 is the sum, it's D. Number 17, let a plus ar1 plus ar1 squared plus ar1 cubed all the way and a plus ar2 plus ar2 plus all the way be two different infinite geometric series of positive numbers with the same first term. The sum of the first series is r1 and the sum of the second series is r2. What is r1 plus r2? Okay, so since they both look the same and their sums are like r1 equals a over 1 minus r1 and r2 equals a over 1 minus r2, right? Then let's just bring r1 and r2 together, and let's say that r1 and r2 are the roots of r, right? Roots of r. And then we'll just use r to express both of these, right? So that gives us r equals a over 1 minus r, right? And so this gives us that r minus r squared equals a. So r squared minus r plus a equals 0. And so we want the sum of r1 plus r2, which is just the sum of the roots, right? So the sum of the roots, this is going to be negative 1 over negative 1. That's going to be 1. So 1 is the answer. It's C. Number 18, for k is greater than 0, let ik equal 1,0,0,0,0,0,0,6,4, where there are k zeros between the 1 and the 6, right? So there are k zeros here, k zeros, and let nk be the number of factors of 2 in the prime factorization of ik. What is the maximum value of nk? Okay, so since this has like k plus 2 zeros, right? So this is equal to 64 plus 1,0,0,0,0,0,0,0 all the way, and there are k plus 2 of them, right? So this is going to be equal to 2 to the 6th power plus 2 to the k plus 2 power times 5 to the k plus 2 power, right? This is going to be 2 to the 6th power, and then that's going to be 1 plus, and then if k is 4, then it's going to be, if k is 4, then that's going to be 5 to the k plus 2, so that's 5 to the 6th power. And then we know that this is odd, and this is also odd, right? And so this is going to be 2 to the 6th power times something even, which is 2 to the 7th power times something. And so this 7 is the maximum value. That's when k equals 4. So that's the maximum. It's B. Number 19, Andrea inscribed a circle inside a regular pentagon, circumscribed a circle around the pentagon, and calculated the area of the region between the two circles. Bethany did the same with a regular heptagon, 7 sides. The areas of the two regions were A and B respectively. Each polygon had a side length of 2. Which of the following is true? Okay, so if we just draw these pentagons like that, and then draw the heptagon, 7-sided thing, like this, the actual shape doesn't really matter, because from the center, we'll say that this length is A and this length is B, right? And since the side length is 2, that means this is half of that, which is 1, right? And the same thing here, let's say this is C and this much is D, like that's right angle, and then this thing is 2, so let's say this is 1, right? So this is 1, right? And so if we look at A and B from here, A is going to be this big thing minus this small thing, right? And its radius are A and B, right? So the radii are A and B. That's just A squared pi minus B squared pi, right? And that's just A squared minus B squared pi. And since A squared minus B squared equals 1 because of the Pythagorean theorem, right? A squared minus B squared equals 1 squared. So this is equal to pi. And for this one, we see that it's C squared minus D squared pi by the same thing. And since also this is a right triangle, so same thing with the Pythagorean theorem on here, then that gives us C squared minus D squared equals 1, so this is pi. So they both equal pi, and so that means A equals B. It's C. Number 20, convex quadrilateral ABCD has AB equal 9 and CD equal 12. Diagonals AC and BD intersect at E. AC equals 14, and AED and BEC have equal areas. So what is AE? Okay, so if we take out a diagram here, so we are going to have, let's label the sides. It's going to be A and B and C and D, right? And then they intersect at E, so this would be E. right? And then AC equals 14, and then AB equals 9, and CD equals 12, right? So let's say that this is an isosceles trapezoid, because that is the only way for this to happen, because AED and BEC have equal areas. That's these two, right? And they have equal areas only in isosceles trapezoid. And so that means we can use the fact that this triangle and this triangle, they are similar, right? And so since AEB and DEC is similar, that means, yeah, AE to EC, so this length to this length, that ratio is the same as this to this, right? So this is equal to 9 to 12, which is equal to 3 to 4, right? So this is 3 and this is 4, but since it said that the whole thing is 14, so this is 14, right? So AE is going to be 3 over 7 of the whole thing, and the whole thing is 14, right? Which equals 6, right? So this is 6, the answer is E. Number 21. Let px equal x cubed plus ax squared plus bx plus c, where a, b, and c are complex numbers. Suppose that this equals 0. What is the number of non-real zeros of x to the 12th power plus, yeah, this one, right? Okay, so since we know that 9002, 2009, and this, they are all roots of p, right? So that will mean px is equal to x minus 2009 and x minus 9002, x minus 9002 times x minus 2009 minus 9002, minus 9002 pi I. So we want this one, right? But then this is just px to the 4th power, right? Px to the 4th power, right? Because we put x to the 4th power instead of x, right? And so px to the 4th power, that's going to give us px to the 4th power. This is equal to x to the 4th minus 2009, x to the 4th minus 9002, and then x to the 4th minus 2009 minus 9002 pi I. Here, the roots, all four roots will be complex roots, and here we have real roots plus or minus root 2009, right? And so discarding those two, that will be 4 minus 2 equals 2 complex roots, right? And since this also has plus or minus roots 9002, and so in the same way, it would have 4 minus 2 equals 2 complex roots, right? Complex roots. So we have 4 complex roots and 2 and 2. So that gives us a total of 8 complex roots. Right? So that's the answer. It's C. Number 22. A regular octahedron has side length 1. A plane parallel to 2 of its opposite faces cuts the octahedron into the 2 congruent solids. The polygon formed by the intersection of the plane and the octahedron has area a root b over c, where a, b, and c are positive integers. A and c are relatively prime, and b is not divisible by the square of any prime. What is a plus b plus c? Okay, so let's bring out the octahedron. It's going to look something like this. And here, we are going to have a plane that's parallel to 2 of its opposite faces. So let's say that it's parallel to these 2 faces, right? And so that would mean that this is a side, and so we would cut it parallel to this one, which is from the half of here to the half of there, right? And then so same thing for here, from the half of here to the half of there, that will be like this. And the same thing for the bottom, from by the half, and the same thing for this one, that will be half, and same thing for this one, that's like there, right? Because this one, that's on the front page, right? That's on the front face. And then lastly, we have this, which will connect the last two together. Now we see that this, that hexagon, that is parallel to this and this, right? So we have like 3 of these stacked in a row, right? And so now we can see that this is a regular hexagon with regular hexagon, right? And all of its side length are 1/2 of the side length of the octahedron, which is 1/2, right? And side length 1/2, right? And so this is going to give us, if we do like that, then that's going to give us 6 equilateral triangles. So 6 times, and then root 3 over 4 times 1/2 squared. And so this is going to be equal to 6 times root 3 over 16. So this is 3 root 3 over 8. And so this is the answer. No, that's just a root b over c, right? And so what we want to get is a plus b plus c. Yeah, so So here we get a plus b plus c equals 3, 3, and 8. That's 3 plus 3 plus 8, right? This is equal to 14, right? So it's 14, it's E. Number 23, functions f and g are quadratic. Gx equals negative f times 100 minus x, and the graph of g contains the vertex of the graph of f. The four x-intercepts on the two graphs have x-coordinates x1, x2, x3, and x4 in increasing order, and x3 minus x2 equals 150. Then x4 minus x1 equals m plus n root p, where m, n, and p are positive integers, and p is not divisible by the square of any prime. What is m plus n plus p? Okay, so to give us like an idea of what this is about, let's just draw those two parabolas. And so we have this function, right? So let's say this is f and the lower one is g, right? And they're going to have a distance between them of 100, and it's going to be centered at 50, right? And so this is going to be equal to 50 because gx and f 100 minus x, those vertices are 100 apart. But then since this is kind of not comfortable, right? Yeah, so we want that line to go to the origin. And so what we're going to do is we are going to slide the whole thing, slide f and g, slide f and g 50 to the left, right? So that's 50 to the left, and so that means f and g, this will become like that, right? That will become the new graphs of f and g. And yeah, so this will be f, and this will be and this will be g. Yeah, but then the other things that we are given, they are x3 minus x2 and x4 minus x1. That won't change at all with this sliding, right? And so we don't have to change any of that. So now we get that this is x1, this is x1, this is x2, this is x3, and this is x4, right? So it said x3 minus x2 equals 150, but then since x3 equals minus x2, right? x3 equals minus x2, right? And so this equals, since this is x3, that means this is equal to 150 divided by 2, which is 75, right? And so x3 is 75 and x2 is negative 75. And here also, same thing, since it's symmetrical now, x4 equals negative x1, right? x4 equals negative x1. And since we want x4 minus x1, this is just going to be equal to minus 2x1. So yeah, let's write this out. This is going to be equal to minus 2x1. Now let's look at the fact that the graph of g contains the vertex of the graph of f. That still doesn't change with the sliding because f and g both moved, right? And so this is the vertex and this is the vertex. They are just like flipped over by, since it's just like a 180-degree rotation by the origin. That means if g contains the vertex of f, then f contains the vertex of g, right? So let's just look at one of that. So let's just write out x3 equals 75 and x2 equals minus 75 first. And so this is a vertex, right? And so f is going to be, so f, this is going to be equal to x1 and x3, which is 75. So it's going to be k times, because we don't know what's on the front of it, k times x minus x1 times x minus 75, right? And so here we're going to have the vertex, and it's going to be, and the x coordinate is going to be right at half between, half between x1 and 75, right? So it's going to be x1 plus 75 over 2. And here, to get the y value, we just have to plug this into here, right? And so that will give us k times, and then minus 1 over 4 times x1 minus 75 squared, like that, right? And that will give us, simplifying that will just give us minus k over 4 times x1 minus 75 squared. Next we look at g, right? Because since this is also inside g, so this is a part of g, and so we'll just put that in the g thing, right? And so if f is this, then g is equal to minus k times x plus x1, right? X plus x1, because x4 is equal to negative x1, times, and then x plus 75, because this is negative 75. And then if we just plug this into here, then that will give us that it's minus k times x1 plus 75 over 2 plus x1, so 3, right? This times, and then all over 2, x1 plus 75 times 3, like that, right? And this equals minus k over 4 times x1, x1 minus 75 squared, right? And so these two are going to cancel, and these 2 and 4 is also going to cancel. And so that leaves us with 3x1 plus 75 times x1 plus 3 times 75. This equals x1 minus 75 to the second power, right? And so if we just say that x1 equals like 75a, right? If x1 equals 75a, then that's going to make our lives much better, because that will just enable us to get out 75 from both sides. So that's going to be 75 squared times, and then a minus 1 squared equals 75 squared times 3 plus 8, 3a plus 1 and then a plus 3. Notice I've changed this around, right? So this part, that becomes this part, and this part is equal to this part, okay? And so that is just ending like that, right? And so we just take out the 75 squares, and then we get a squared minus 2a plus 1 equals 3a squared plus 10a plus 3, right? And so this is going to give us 2a squared plus 12a plus 2 equals 0. And so a squared plus 6a plus 1, this is also equal to 0. Here we use the quadratic formula. So this is going to give us that a is equal to minus 6 plus or minus 4 root 2 over 4, right? And that's just equal to minus 3 plus or minus 2 root 2, right? But then since x1 is over here and x1 is 75a, that means a is also not just negative 1, right? And so a is less than that, so that means this should be a 3 minus 2 root 2, right? And so since a is equal to negative 3 minus 2 root 2, then we can get then we can get the value of x1, right? And so here now we see that x1 equals, now x1, this is equal to 75a, right? Let's do that in green. x1 equals 75a equals 75 times minus 3 minus 2 root 2, right? Minus 3 minus 2 root 2. This is equal to minus 225 minus 150 root 2. Since what we wanted was negative 2x1, that means this is going to be equal to minus 2 times minus 225 minus 150 root 2, which is going to be equal to 450 plus 300 root 2, right? And so we get the values of 450, 300, and 2. So 450 plus 300 plus 2 is going to be equal to 752, right? So this is 752, it's D. Number 24, the tower function of 2's is defined recursively as follows. t1 equals 2 and tn plus 1 equals 2 to the tn power for n is greater than or equal to 1. Let a equal this and b equal this, where is the largest integer case such that this is defined. Okay, so let's just say that doing log 2 k times on anything, let's just say this is lk. Doing it k minus 1 times, that would be just lk minus 1, right? Now for this to be defined, so for this to be defined, that just means that 1 minus this, so this much, that has to be greater than 1, right? So that means that's just lk minus 1, right? lk minus 1, because that's doing a k minus 1 times of b. This is greater than 0, right? And this is greater than 0 if and only if 1 less than that, so this much, which is k minus 2 times, means lk minus 2 of b. This is greater than 1. This should be possible. And so this means that b is greater than 2 of the 2 power, and this would be k minus 2 times, right? But then we have a function for that. It's called t, right? So this is going to equal, so that's going to equal t to the tk minus 2, right? So b is supposed to be greater than tk minus 2. We know that b equals t2009 of a, which is t2009, b equals t2009 power to the t2009 power, right? But then we know that this is greater than 2 to the t2009, right? And this is just equal to t2011. We know that b is greater than t2011, and so that means this and this can be equal, right? So that means tk minus 2 equals t2011 is possible, right? So that means k is 2013 is possible, Since k is 2013, that's the largest answer choice. That means there won't be any larger k than that. So that means k equals to 2013. That is the largest integer k. It's e. Last problem, number 25. The first two terms of a sequence are a1 equals 1 and a2 equals 1 over root 3. For n is greater than or equal to 1, an plus 2 equals this much. What is the absolute value of a 2009? Okay, so first we see this equation, and if you see, this is very, very similar to the tangent addition formula, right? Tangent addition formula. This is because, and this is because tangent of like any two angles, like a1 plus a2, this is going to be equal to tangent a1 plus tangent a2 over 1 minus tangent a1, tangent a1, tangent a2. This means that if we just say that an plus 2, that's just the tangent a1 plus a2 thing, then that means that an plus 2, this means that an plus 2 is always going to be equal to an plus 1. No, I should use a different value. So this should not be a, let's say it's x, to differentiate from the real an's over here. And so let's get rid of everything a and put them x instead, right? And so tangent x1 plus x2, this is equal to tangent x1 plus tangent x2 over 1 minus tangent x1, tangent x2, and so xn plus 2 is equal to xn plus 1. But then this, note that this is mod 180. Note that this is mod 180 because tangent theta rotates by 180 degrees. So if you look at the tangent graph, then it repeats itself every pi, right? So from here to here, that's pi, from here to here, that's pi, and so on, right? Since we know that a1 equals 1 and a2 equals 1 over root 3, then this gives us that for these a values, the x values are, 1 is tangent 45 degrees, right? And 1 over root 3, that is tangent of 30 degrees. So that makes it kind of like a Fibonacci sequence with angles, right? And so since this is just all going to be multiples of 15, let's just say bn. Let's make a new variable, bn. This is just an over 15. That will make things a lot easier for us, right? And so starting from 3 and 2, because that divided by 15 is 3, and this divided by 15 is 2. And so that gives us bn is going to be equal to 3, 2, 5, 7, 0, 7, and then we add 7, and then we get 2, and then we get 9, and then we get 11, and then we get 8, 7, and then we get 3, and then 10, 3, and then 10, and then 1, and then 11, and then 0. This is going to be really long, right? And then 11, and then we have same thing, 11 again, and then we have 10, and then we have 9, and then we have 7, and then we have 4, and then 11, 3, and 2, right? If we count all these, so this is going to be repeating, right? But then if you count this is 24 numbers, right? Repeating 24 numbers. That means b 2009, let's say, because bn is just an over 15, b 2009, this is going to be b17, right? Because 2009 is 24 times something plus 17, and so we want to see the 17th value here. So this is 5, 10, 15, and so this is the 17th value, so this is 0, right? And since bn is an over 15, so an is going to be equal to 15 times bn is going to be equal to 0, right? And so n equals 0. That's our answer. It's A. So that was the last problem of the AMC 12A from the year 2009, and thank you for watching.